Hello, I am Idris Tekin. In this numerical analysis assignment, we implement the Newton-Raphsone method to find the roots of a given equation. The chosen equation for demonstration is fx x squared minus 2x and minus 8. And first derivative of its equation is 2x and minus 2. I took derivative of above equation, and then I give a range of values for x from minus 10 to 10 with a step size of 0.5. Then to evaluate the function f at each point in the vector x and stores that results in the vector y. Here we plot the function represented by x and y, and I give a name for this graph. I give title graph of input equation. I use this because of I want to show our graph on the x and y axis. Then here we want input from users. Its initial point takes user inputs for the initial point. Then we here wants number of iteration, and this takes user inputs for the number of iterations. Here desired error values, we can say wanted error values. Here we this line takes user inputs for the minimum error values, and here I assigned initial point to variable x0 to make the calculation simpler, just for that. And here we initialize an array to store errors for each iteration. It is create a zeros array for each iterations. Here this means is that for each value of I from 1 to number of iteration, do the following block code. Following block code is that here is that say it is say that and x1 I use Newton-Raphsone formula in here, just that it calculates a new estimate x1, and I use error formula in here, and it is print of our iteration number, new root, and error of this iteration in here in this line. Here we store the error for plotting, and here if the minimum error will be lower or equal than the value of we want, code will be break. And here we plot location of the estimated root by our point, it's red color, and give a plus marker in here. This we force the plot to update, and we here in each iteration it calculates a new estimate x1. Here we plot the errors for each iteration and give a name for this plot, and give name for x label and here y label, and let's use that. This give us a graph of input equation. Enter the initial point value, let's say 9, it's not important, and enter the number for iteration. Let's give 10 iteration. Enter the minimum error value, let's say 0.0001, and let's look. It's give us 6 iteration because our minimum error is being equal or less than we want the error here. It's already give us 4, our one of our root. And let's look graph and figure. Our figure 1 here, it's give us estimate roots, this red and plus marker here. And this is our graph of input equation. Here it gives us errors for each iteration. For instance, its first iteration, it's give us 38.19 error value. Here is go until 10 iteration. That's it for Raphsone method. Thank you for listening.